I recently tested, and this fella's with that company, Fuzz Gummer, and I was quite pleased with it. And I tested it, but it really gives best results using just what they say as well, the Analog Productions test record. And the reason why I like the new version even better than the old version is that if you use the Analog Production test, I found, with small amount of testing, using the Analog Production test record and a fresh battery or plugged in, because it needs to have full power. And then I prefer taking the signal not from the tone arm, but from the phono stage. Why? Because from my limited experience, the meter is much more likely to give me absolute decibel, closer to what are actually absolute decibel readings. So the meter is measured 0 to 50. So what I found is that when I used it in that configuration, I got closer to what the real decibels are. Why would that matter? Because occasionally you'll get a defective cartridge where you can balance the two channels in crosstalk, but you do so at like 23 dB. Well, that cartridge needs to go back to the factory. And if you can know what the actual decibels are, you can avoid those problems. It doesn't happen often, but it happens. So I like to know what the actual decibels are. So in those conditions, I found that the new version of Fuzz Gummer gets very close. If you don't have a Fuzz Gummer, you can use a multimeter, but you won't have the filtering component and it's more of a pain in the ass, of course, than a Fuzz Gummer. And if you want to learn how to do it with just a standard digital multimeter, you can go to the blog, and that will just lead you to Michael Fremer's website, which gives you the instructions for that. Okay. Azimuth is the last step to perform in the alignment process. I've got videos on all of the tools and on the process of setup. And that you can find, I did one video on what process to take, what steps to take in order. There's a certain order you want to take because, well, each alignment factor will tend to influence other alignments. So you want to take it in an order, a sequence that is least likely to cause you have to go back and redo something. Okay. Indirect azimuth tone arms might need one more step after aligning azimuth. Indirect azimuth tone arm is a tone arm that has the azimuth adjustment mechanism, and I'm speaking generally here, has an azimuth adjustment mechanism that's back at the pivot point. It's back here. Why is that important? Because those tone arms, when you adjust the azimuth on an indirect azimuth tone arm, you're also changing rake angle. So if you care about getting your rake angle spot on and you know that you've adjusted your azimuth, say 1.5 degrees, I've got a calculator on the website for you to determine what change did you just make to your rake angle, and then you can raise or lower the tone arm accordingly. All right, so rake angle. So the only science that exists, and it's not very robust science, on what is the ideal playback rake angle, that was done in 1981 in Audio Magazine by fellows named Risch and Meyer, and they came up with 92 degrees as the ideal average. They did not specify whether that was dynamic or static. And what I mean the difference by that is when you drop the stylus to a non-moving record, that cantilever is going to be relaxed, but as soon as the frictional forces kick in of a moving record, what happens? The cantilever goes boop. Now, I analyze a lot of cartridges. People send them to me for their ideal angles, and I've seen a variation of that dynamic change anywhere from as little as 1/4 degree up to 2.25 degrees. But most are about 1 degree. Most are. And that's not purely, it's not 100% a function of the compliance. It's also a function of the starting angle of the cantilever. If the cantilever was way up here, then it would be a big change. If it's way down here, it'd be almost no change. There are other publications on rake angle in the Journal of Audio Engineering, but they're rather immature because back when they were actually publishing scientific studies on vinyl playback, there weren't very few fine line contact style yet at all anyway. So they were focusing on the angle of the cantilever. Like I said, I think you can make an argument for the quietest screws are cut at 90 degrees, at less than 90 degrees, but there is something called springback. When the cutter head stylus scrapes through the lacquer material, it's heated. The stylus is heated, and the lacquer goes into a semi-gelatinous state. And when it cools, there is a springback effect, and there's been some papers written on that. So even though the cutter head may have been aligned at perhaps less than 90 degrees for functionally for playback, that may not be where it rests, where the groove rests. Okay? That's incomplete science. So it's arguable about what's the best. It really is. So this is just remember the photograph I showed you of the microscopic photograph of the test track. And you remember those undulations. Now just turn them on their side. And those are vertical. Now turn them on the side, and I'm representing them here with these bars. And now we can see through the groove to a stylus that has been oriented with a rake angle, and you can see if the rake angle is significantly different in the high frequencies versus how the groove was cut. What this fine line stylus can do is just skip from groove peak to groove peak and not actually reach all the way down into the basins, right? So again, that's a mechanical distortion because it's not reading the entirety of the groove. Right? Any questions so far? Okay. So how to optimize rake angle? The only reliable way to do it is using microscope. Now I did a webinar that I have recorded, and it's available on the website, that had Fremer and Greg Weaver and Mark Doman from Doman Audio kind of as my panelists, where I showed how to measure dynamic rake angle using a USB microscope. But I wasn't comfortable doing that webinar because, well, on one hand, I knew I could help people improve what they were getting with the equipment they had to improve their accuracy of the results, because a lot of people expressed tons of frustration, and rightly so, with those USB microscopes. On the other hand, I was uncomfortable because I knew that the resolution on those are really bad, and it's difficult at best. So I wasn't planning at the time, but I ended up making the Wally scope, which is a hell of a lot easier and much more accurate. So, but to measure that angle really requires two steps. You're going to measure this. You're going to measure first the relationship between the cantilever and the contact edge, which is right in the center. And then, once you've done that, measure using the spinning disc. And I've got this disc that I include. This is kind of cool. So I go to Goodwill and I buy all the records that will never be purchased. Here's a Carpenter's. And I assess them for flatness, and then I trim off the outer edge, the outer lip, so that I can get down so that now this record has the groove right at the edge of the record. And why do I want that? Because if I'm going to take images like this, I want my reference line to be nice and crisp. Nice and crisp. So that means I'm going to drop the stylus right at the very edge of this trimmed record. If this weren't trimmed, this would be so blurry, and I'd have a tough time getting that angle down. Right? I would say that rake angle of all of the three axes is the one least influential on the playback. Zenith and azimuth have much more influence on a degree for degree basis. Notice I didn't say raising and lowering the tone arm doesn't have any. When you raise and lower the tone arm, you're affecting more than just rake angle. Depending on the type of tone arm you have, many of you are also changing your vertical tracking force, which changes a whole host of things. I won't even go down that road. And also many of them, you're also changing your azimuth angle. Many, but not all. So that's how there's all these instructions are all on the website. All right. Zenith. Okay. So these are the kind of pictures that looks like a worm, doesn't it? So these are the kind of pictures I take with my lab microscope, and this is a very difficult image to get. As I said, my microscope cost more than my car. That was difficult enough. And then I had to learn how to use it. And I spent a lot, I had to hire a material scientist to teach me how to do this, right? So you'll see, and so where the contact edge is right here. That's it. That's it, right there. And you can see, just looking at this, it's not perpendicular to the cantilever, can you? Yeah. This is within tolerance. If you sent this back to the factory, and if it's to the cartridge manufacturer, and if they could measure this, which I don't believe any of them can, maybe Ortofon, this would be returned right back to you, right? But yet, this is exactly what we're trying to align so well when we align our cantilever. Because remember, that's our proxy for this, okay? Now, people send their cartridges to me, I can analyze them, tell them you are 1.75 degrees clockwise error, and then there's a way to fix it with the Wally Zenith. This is all correctable. I'm gonna work on, using the Wally Zenith as well, there is a way to potentially subjectively assess for Zenith error. It will be a pain in the ass, but not just for me to write the instructions, but for you to do it. But it's doable, okay? All right, so